Hello, I'm Eric Snodgrass, and thank you for watching this in-depth ag forecast brought to you by Nutrien Ag Solutions. As we check in here on Thursday at the last 7 days of total accumulated precipitation, for me personally, I'm just looking back at model performance first of all. And it's been this corridor that the models had opened up for quite a bit of thunderstorm activity. And they did quite well on predicting some drier conditions in places in Minnesota, the Red River Valley of the North, and in just parts of the Canadian Prairie, but have done quite well over time, just picking up on this pattern of storms rolling through the midsection of the country and then pulling on off toward the north and east, and even picking up on what became Tropical Storm Alex's path did quite well. Now, many of these storms in the midsection of the country were quite bad. In fact, I was over here for several of these earlier this week. And just looking back on the hail reports from this, I was kind of zoomed in here looking, but this is just the last 3 days worth of hail. We're looking at a product called maximum estimated hail size. So the color coding here tells you the size of it. And just for reference, these colors in through here indicate 3-inch diameter hail. Now, the majority of this, even though there were some storms in the Pacific Northwest and some in the eastern Corn Belt, but it was right here in the central U.S., where some of these storm systems were putting down up to softball size hail. So there was a lot of damage done on this crop. I would like to make one quick comment about this. Where my travels took me this week is I started in Champaign, went up to the Quad Cities, ran across I-80, go over to Council Bluffs, down to Kansas City and back, okay? And one of the things I noticed, just for those that are watching from the corn and soybean belt, is that the crop in this area was very uniform. It looked fantastic, but it all looked just about the same height for both corn and soybeans. And of course, it was behind. I did see some damage in and around the Omaha area, and I'm sure there was a lot more back into parts of many of these central U.S. states as we went through this pretty nasty week in terms of severe weather. And if you didn't get hit with the bad parts of it, there was just a lot of flooding in them as well. Now, as we look forward, today we're watching very carefully that same region. So we're going to be watching for storms to fire up here, coming off of the high plains into the central plains, right down to the Red River Valley of the South. And then in tomorrow, Storm Prediction Center upgraded to an enhanced risk over this part of Arkansas into Louisiana and Mississippi. So right now, just looking at some satellite imagery, kind of going back in time here, we're watching these storms kind of roll off of the mountains here. It's a really amazing thing to see them come off of the Rocky Mountains in the Front Range here, while a front kind of sags down here right along the Gulf Coast. So this is what we're dealing with right now. And the next system we've been caring a lot about is entering the Pacific Northwest. So if we just take the pattern as it is and say, what are we getting here in the very near term? This is the 18Z high-res NAM model, and it's just kind of looking at total accumulated precipitation. So we can kind of get an idea on where we're expecting to have those storms roll through as we go from Thursday evening through Saturday, early Sunday morning. So we're going to watch this corridor carefully with a lot of isolated severe convection here. We have a couple other places that we're just keeping a very close eye on in the midsection of the country. A lot of scattered convection down over the southeast, getting up to the Appalachian Mountains. And then it's this next system nosing into the Pacific Northwest that's going to get a lot of my attention, again, starting tomorrow, but going through the weekend. I'll show you more about that in a second. Now, just noticing how much moisture has come into this area, I want to just show you a quick series of images. Now, these are all coming from NASA. And we're going to go month by month back all the way to March. So it's going to be March 9th, April 9th, and so on. Now remember, the soil moisture values down to 16 inches were incredibly dry from Texas all the way through the western Corn Belt and also along this part of the southeast coast to the mid-Atlantic. We then fast forward a month, and it was so wet down here, we eliminated a lot of that early season drought risk while it remained here through April. We could also see pockets of it remaining in like the Golden Triangle and in California, a place we've continued to discuss about water shortages going forward. You then get into the month of May, and that's when the strong Pacific jet just targeted from very northern California through Oregon and Washington, and systems ejected here into the northern plains, which is what caused all the flooding that was in southern Manitoba, North Dakota, parts of South Dakota, and Minnesota. And the drought area at times kind of shrunk back farther to the south throughout early May, as heavier rains did come into parts of Nebraska, just as an example. It was wet through Pennsylvania as well. So just kind of getting a picture here. And then this is today. All right. So we see here quite a lot of shift over the last several weeks. But this is just one way at looking at soil moisture. And I'll be honest with you, and all of my colleagues would agree, soil moisture modeling is one of the most difficult things that our weather forecast models are attempting to calculate. So when you look at this map, you can compare it to something from the CPC, and that's what we've got here. It's always a couple days old from the CPC, but this is the June 7th calculated soil moisture ranking. So when we see this, we see very low ranks from California over to the high plains and southern plains. It's been extremely wet in through here, also in the Red River Valley of the North. But now you can start to see that golden triangle spot that's been so dry versus where all the storm systems have entered the United States lately into this part of the Pacific Northwest. So let's put both of those together and then maybe pull it all together by looking at the latest drought monitor, which came out today. This is the one here today on June 9th, came out early this morning, and we still see about 60% of the country in some form of drought, 60% of the lower 48 in some form of drought. And, big reservoirs in California, like Shasta's at 40% full pool, Oroville's at 53% full pool, and we're just into a full-on summer pattern. Evaporation rates with the heat that's coming in here could possibly exceed 3.5 to 4 inches this week, just due to the heat, not only in California, but all the way down here into southern Texas, this whole region in the southwest. And that's because the jet stream is still doing this. There's the extension that we've been talking about now for about 45 days. So it's just running straight into the Pacific Northwest, but you notice where the flow is weakest. It's that area that drought's developing. Now, the big questions that I've had, and we're going to have this discussion going into the longer term now, is we've seen now for almost a week evidence in the models that by mid-month this shuts down. And we're going to have a discussion about what the implications of that transition are going to be. So first of all, as this comes slamming in, I want to show you what the models do with it beyond the next 5 to 6 days. So there's our long, almost unbroken and continuous jet we've been discussing. Here's just the latest iteration. So going through the 10th, going to Saturday and Sunday, and out there to early next week, do you start to see it breaking up into multiple shorter waves at times with a region of ridging that's going to show up right here in the midsection of the country. Now, what we notice is that from the 13th through the 14th, 15th, 16th, the jet stream starts to make a poleward shift, which is normal of early summer. And it just continues to get into this configuration where there's a ridge north of Hawaii, there's a ridge somewhere between Texas and South Dakota, and almost split flow here in the North Atlantic. Now, that triple ridge pattern, 1, 2, and 3, just like that, is a pattern we will be very concerned about seeing, both in the near term, but more in the fact that it could get repeated and stick around all the way through, the early part of summer. So I'm talking about through the beginning of July, because it's certainly out there day 10 and beyond. And I know the models kind of lose some of their, because of the ensemble spread, they lose some of the defining features. But this has been a very robust signal all the way out there past the 20th of the month. And breaking up that long and extended Pacific jet, well, we're going to talk about possibly why that's occurred, but it is actually typical of this time of year. It's the placement of the ridges that's unique compared to recent time periods. Because this time a year ago, this large ridge right here was there. So you can see it's almost a half wavelength. If you just think about the wavelength of the jet stream pattern, it's half wavelength shifted. And that's going to mean an entirely different summer start for many folks. So let's take a look at it kind of piece by piece. This next week, I just pulled up this map here from the European model showing you precipitation anomalies. So we already start to see sections in the Midwest, parts of Texas and the southern plains showing up much drier. Whereas we still have all that momentum coming into the Pacific Northwest. We're going to watch a system come out and eventually curl up here into the Canadian Prairie, bringing more wet weather into the northern plains. Let's go have a quick look at that by doing our multi-model analysis here. So European models on the right, GFS is on the left. So as we play through Thursday night, and again, we can see the thunderstorm complexes in both models here. Now, these are our lower resolution models, so they're not going to resolve it as well as some of the higher resolution models will. But as we go into Friday morning, what we end up getting here is a stalled out boundary through Friday, comes right into this area, and it's still there through Saturday morning as the thunderstorm complexes continue to advance through parts of the south. Now, after that, there is a deeper low that's going to come into the Pacific Northwest, and we can start to see it here as we work our way through the day on Sunday. There's another one that's moving out of Ontario into Quebec, and it's in both models as well, increasing the chances for storms into parts of the Eastern Corn Belt and Great Lakes, but into New England. Again, scattered convection down here in the southeast, typical of summer heat. What we notice is that going from Sunday into Monday, And then eventually to Tuesday. Do you see it all rock back and forth? That's basically Sunday night through Tuesday. There's a low that comes off the end of that, the nose of that jet, and just sits up here and spins. And what's going to happen is we're going to bring in a lot of heat south of this. Strong southerly winds pulling up moisture. There will be storms that fire in this. But right now the frontal boundary is relatively weak and it just extends right in through this area. Okay, so that's Tuesday afternoon and evening. And then once that goes through, you see how the storms kind of roll around this? We're going to watch for that midweek next week. The pattern just, you see how north it goes? That's an indicator of the jet stream shifting to the north. And when it shifts to the north, that is going to limit the speed of the winds here and therefore limit the development of systems. And the net effect of that is you go out there into week 2, we end up almost developing, I guess we could call this an omega pattern. It kind of looks like that. But it's a highly amplified jet stream pattern favoring a ridge in the midsection of the country. So you end up getting a week 2 precipitation pattern that draws in moisture for the southwestern monsoon on the heat, but the storm track goes north, and then we see here a larger area of drier conditions. And there will be isolated convection. Storms pop in an environment like this, but with all the flow north of it, it's just, we don't have the adequate kinematics, the movement of the atmosphere to develop systems that cover more than just a small thunderstorm complex. So we put all that together and add some context to it. Let's just take a look at these next 2 maps. This is the 15-day precipitation anomaly forecast. So today through the 24th of June, looking at the European ensemble. So now you see the effect of those 2 things. And what I'm concerned about is for most places, this will not be problematic. Where it will be problematic is probably best seen in this map. What you're looking at here is the previous 14 days. And I start to pick up on regions right in through here, or in this part of Indiana and Illinois, Missouri, Arkansas, or this section here of Arkansas, Louisiana, and much of Texas. Same thing in the Panhandle. Or what about here from North and South Carolina up into parts of Midland? See those drier pockets? Those are going to be the regions that, as the drier conditions and the heat builds, could see some early season crop stress. And I'm going to have to watch these areas, very, very carefully. Now, from there, I do want to show you what the temperatures are going to do. So we've already experienced these temperatures today on Thursday. Let's get to Friday. Triple digits in Texas, deep in the 90s in the Great Basin and the Intermountain West. Triple digits, and this is why we have excessive heat warnings throughout the Central Valley of California. Phoenix, you're going to grab 112. This cooler weather is on its way out in the midsection. Now watch this. They're going from Friday into Saturday, then into Sunday. That ridge begins to open up, the first in a series, begins to open up, spreading, triple-digit heat, possibly as far north as, maybe into parts of Nebraska. It could get there. But that's Sunday, and Monday, I think we're going to be there. And now we go over to a big section here in the mid part of the country of midsummer heat, while the Northwest has another round of colder weather. And then we see going into Tuesday, I live in Champaign, we're expecting a high of 97 degrees. That's hot for us on July 14th. That's a very hot summer temperature. And while we get a little brief shot, now remember, this is when that big low is curling up here, so you're getting the cold front kind of coming through. But it's weak. It's only returning temperatures back to what we would consider normal. And this is all before the next ridge comes in after the 15th. So what I'd like to show you then is the temperature pattern. Now let's go here. Next 5 days, colder air exits east, warmer air builds while the cooler air comes in into the Pacific Northwest. We're going to stop this out here day 5 through 10, which gets us out to the 19th of June. Now from that point forward, you'll notice that the ensembles are keeping the pattern around, allowing it to get stuck, possibly blocked up, and stick around looking something like this. In fact, when we look at the new CPC data today, they have, let's shrink that up so you can see it, they've now got this large area here and then back in the mountains where over these 2 different time periods, they're looking at a slight risk of excessive heat and a moderate risk of excessive heat here on the 16th and 17th. So this is all week 2, but we're trying to identify what the impact would be of kind of delivering all of that heat into this region. Now what's important about that is the Northwest, which has struggled to build in heat this year, going back over to the cooler pattern, they're not going to see much of a change. But Texas, which is having probably a top 5 warmest spring on record, we're going to start to see that heat building north in this whole area and east from there. So this map is going to take on a lot of change. It's one I show you all the time, the temperature ranks maps. It's going to take a lot of change here when looking at the May through early June versus possibly the early June through early July time period. We're going to see a lot more warmth in this area. Okay, we now get this idea on where we're going. What I want to talk to you about next is the agronomic impacts first, and then what I see about in the longer range. First of all, there will be those stressed regions in the near term that didn't have the recent precipitation. You're going to get higher evaporation rates and with that heat. But we will make up this deficit very quickly. So this map will change a lot in terms of GDD, growing degree day anomalies. We're going to see these numbers really make up quickly with the heat that will be coming in. Not here, but here, okay? So on the other side of this, I'd like to show you this map. I produced it this morning and put it in my report, but I want to have a discussion about it. It's the latest sea surface temperature anomalies. We know that right here in Niña region 3.4, we've actually pulled back up to an average temperature there of a ½ degree Celsius below normal. So that's technically meaning that this region is going closer to what we would call INSO-neutral conditions. But there's still a La Niña. The Mjo, I'll talk about the Mjo in a second. The Southern Oscillation Index is still negative, about -18. We still have cooler water here and some cooler water just off of the Pacific Northwest. Now that region right here, I'm trying to fold into the pattern. You do get sensible heating from the ocean into the lower atmosphere. And the warmer we make it, the greater the atmosphere attempts to expand. That's part of a thermal wind relationship. That's part of that actually goes back to ideal gas law, first law of thermodynamics. So what I'm trying to tell you here is that if that occurs, it would make sense for more ridging events to take place here. And then downstream, just because of the typical wavelength, we'd have troughing there and a subsequent ridge here. Last year, this warming trend extended at this point all the way to the northwest. So last year, the ridging happened there, and there was troughing around the Great Lakes. So you see, that's that shift in wavelength that I'm concerned about. Now, thinking about that, thinking about the placement of this warm water here and some of the behavior in the North Atlantic, it could be that we're getting some split flow around this feature as well. See how there's warmth north and warmth south. It could be just along the periphery that we get our fastest winds. I got to look into that more in more detail. But just thinking about that, I'd like to show you then what the new European weeklies did. This just came out about an hour ago. This is June 9th to July 9th. And as I slide this forward, it's a 1-month sliding window. Now I could show you the model trend, but I'm just going to tell you that the model trend has been toward maintaining this pattern. So let's leave it here, June 20 to July 20. The models are attempting to keep what they've just forecast for the middle of June around for about a month. In other words, favoring more ridging events here than troughing events. It does not mean, be very careful with this, it does not mean that it won't rain here. It's just a setup that delivers less jet stream level wind over the top of this region, meaning that there are fewer fronts in this area, and therefore the organized precipitation is going to avoid it. You still get storms, but they're hyperlocal events. We do see another signal, a pretty robust southwestern monsoon. But along the coast, we see above average precipitation because there will likely be storms that cascade over the top of this and run down. We call those ridge riders at times. It doesn't get stuck permanently. It still moves, but it's going to favor something like this. The temperatures, as you can imagine, are going to look very much the same. So that builds in a lot of heat during that time period. So now our concern over the redevelopment and expansion of drought in places is elevated. We've now seen, this is like the 4th model run in a row from the ECMWF weeklies that has confirmed this. So that trend is there, the consistency's there, and that starts to increase our confidence that this risk could be substantial. So we're going to have to watch this carefully. I got asked a great question today, and the question was, well, how does the Mjo play in with all of this? Because, when we look at these ocean temperature patterns and we talk about the Mjo, which is a feature that kind of runs throughout the tropics here, I just want to show you how the Mjo has a relationship with this. So there's a site I love to use. You've seen me use it before, but I'm going to show you the first part of the site. Now, it is in Italian, but the data analysis is great. I'm reproducing this right now, working on it with an intern. But what you've got here is you got the categories Niña, Niña, and nada. So that's El Niño, La Niña, and nothing. And you see there's a color coding here. Now, some of you watching this might be able to read Italian. What you're seeing here is that going from this color to these means that we've got a lot of observations at a given phase during a given La Niña or El Niño event, fewer and none. Now, the month we're concerned about is Lug, which would be July. And what you're looking for is this color or this color. Now, let's not look for it at the beginning. Do you see how this section, which goes from Niño 3, 4, 5, 6, and 7, that's MJO phase 3, 4, 5, 6, and 7, that those are not common phases, especially when there is a La Niña in July. What's common is phase 1, phase 2, and a little bit with phase 8. Now, what's the point here? The point is to say that if we have a La Niña and we go into phase 1, which is historically where the La Niña during July likes to put the MJO, you get that ridge north of Hawaii, the trough along the west coast, some other sense of ridging here in the North Atlantic. Now that looks very similar, right? So the flow comes around, over, and up. That's weaker flow here, and that's the risk of higher pressure. So that's consistent. Let's do another one. What if we come down here and look at La Niña in phase 2? Now it's blue, so there's fewer, but we're going to have a look at it. Again, what it tends to favor is some sort of troughing here, ridge north of Hawaii. And that trough sends all of its momentum north, and we tend to get more jet stream ridging here and here. So there's some consistency there as well. We say, well, what about down here? Because all these other phases really can't really rely on or use. But what about La Niña in phase 8? We have some, okay? So we click on that, and once again, there seems to be troughs along the coasts with 1, 2, 3 ridges. So when I show you the latest Mjo forecast, let's blow that up. This is now the forecast over the next month from today to the 10th of July. What we don't anticipate seeing is that the Mjo comes way out into the Indian Ocean and sweep over the maritime continent. Instead, it's likely going to stay over here and come back out into this region. And if it does, it's supportive of the pattern that we just looked at. So that's the connection. Now, if it doesn't, we'll get a temporary change in the pattern. And yeah, the two things can operate independently. There are many things that can sweep through, like a blocking pattern in the North Atlantic, some sort of, maybe a tropical system that upsets the flow. All sorts of things can occur to shift us away from getting somewhere like this in the jet stream pattern and getting stuck there. But it looks as though at this point, based on some model forecasts in the analysis, that the risk is there. And that's what I wanted to convey to you today. Now, I'm going to watch the trends all weekend, and if anything changes, we'll be sure to alert you of it so that we can see what that's going to do. But with that, I'll wrap it up. I appreciate your attention today. Have a good rest of your week and weekend, and we'll talk to you on Monday. Thank you.